Good morning, everyone. Boker Tov. How's it going? Second talk of the day. You feeling fired up? Ready? Node.js. We love Node.js, right? We are going to talk about reactive coding patterns in Node.js. But in order to do that, I need you all to do me a favor. I need you to pack your suitcase, pack your bags, because we're going to go to the airport. But we're not going to go to just any airport. We're going to go to the airport of JavaScript nightmares. That is right, because often we can run into these issues whenever our memory load, when our application load becomes too intense for our applications. We start dealing with things like unhandled rejections and memory leaks and all sorts of issues. Well, I am going to help you, guide you through this process. I will be your flight attendant for the next 30 minutes. My name is Ben, and I used to work at Couchbase, but now I'm at Arbitrum. Woo! As a senior DevRel engineer, and you can find me online everywhere at hummusonrails.com and all other sorts of things. I am an old Ruby on Rails developer, hence the board member of Ruby Central kind of thing. And I did just recently publish my first technical book. It took a long time. I hope to at least make enough money on it to buy a cup of coffee at Aroma. Very, very exciting. And I'm also grateful for all the reviewers of the book, including our very own Liran Tal, who helped review the book. I really appreciate his thorough analysis and review and his kind words. If you want to learn vector search with JavaScript, you can get the ebook, you can get the paperback, you can just talk to me during the coffee break, whatever you choose. But I would prefer that so I can at least buy one cappuccino based on this book at some point in my life. So let's get going. You're scanning. I'm not going to turn down a scan. Come on. I'm going to wait a second for the scans, of course. Please, I will sign your book for you even. Okay, so we want to go from applications that feel like they stall under great amounts of load, particularly our Node.js applications. We want to go to something more unified in experience, more cohesive, more holistic, that feels like it flows. That's the experience we want to turn our user experience into. We do that with something called reactive coding paradigms. Who's heard of reactive programming patterns? Oh my, why are you in this room? Go somewhere else. Just kidding, stay. Yes, so that's excellent. So for some of you, this will be a review. For others, this will be the wonderful welcome to the wide world of reactive patterns in programming. It is an exciting world, and I am excited to take you on that journey. But before we do one last bit, there is a duck hunt challenge. Do you remember in the beginning of this thing, the beginning of NodeTLV, they mentioned there's a duck hunt. You can win all kinds of tokens to get great prizes from the sponsors. Wait to the end of this talk for a little challenge to get all my tokens if you want them from me. But you have to wait until the end. Okay, so reactive code is about pushing data, not pulling data. It's about streams, not snapshots, and it's about events as your paradigm, not control flow. What does that all mean? That sounds lovely, but what does that actually turn into? Well, we know that Node.js thrives on async. We have all gone through the journey over the years on the various permutations of how to do asynchronous programming in Node.js. There's been many versions of asynchronous programming in Node.js. We're all familiar. Some worked better. Remember jQuery, some worked less. Some were all over the map. And async and await is our standard pattern that we use and we love it. But sometimes it can be challenging. Sometimes, particularly around a lot of load and a lot of issues, it can expose things like our spaghetti code. Now, that guy there looks really serious. He would never write spaghetti code, although he's hiring for front end, so maybe he would, I'm not sure. Just kidding, we love front end developers. But we would never, ever write spaghetti code, right? But sometimes if we happen to have done so, And it gets exposed when we start dealing with a lot of load, a lot of usage in our application. We start experiencing things like memory issues and all other sorts of problems, like unreadable nested logic. You've ever seen those, just that nest upon nest upon nest to deal with issue upon issue? You're shaking your head because you know it firsthand. It is really challenging. We deal with unreadable nested logic, unclear backpressure behavior. Our error handling, which we thought was so stellar, so amazing, gets exposed when suddenly users start using our application. We build our applications in an amazing vacuum. We call that vacuum the localhost. And then suddenly people start using them. And if we're really lucky, a lot of people start using them. And the things that we built that work so well, suddenly our DevOps colleagues start turning to us and saying, I told you so. I told you so. You know that thing called Kubernetes that was there for a reason? I told you so. Suddenly the issues become to the fore. Well, that is exactly where reactive coding paradigms come to give structure to our asynchronous programming. That's its purpose. It is not for every situation and every circumstance. It is there to help us with applications that need it with that kind of pressure. So in order to really get into it, though, I want to show you a couple examples. But before we get there, now a lot of hands raised for reactive coding paradigms. You're going to know these. These are not unfamiliar to you. For the rest of you, these are going to be brand new insights. You're going to leave from NodeTLV saying, I am a reactive coding guru. I am a master of reactive coding patterns. You're going to feel amazing about yourself. You're going to go home and tell your partner, I am a reactive genius. And they're going to be like, a what? Okay, like, where are we ordering from Wolt for dinner tonight? Like, that's all they're going to care about. But let's cover the concept. So you've already heard me mention briefly the word stream. Streams in reactive coding is sort of like the foundation stone of it all. Streams is your data flow. It's the data coming into your application. Instead of pulling data from your database, let's say, or from other data sources, the data comes. Now, if a tree falls in the forest and no one hears it fall, does it make a sound? Yes, it makes a sound, fine. But did it make a sound for you? No. Because streams happen. The data happens whether or not you are watching it. How do you watch that data? You watch it with observables. Observables is your second core concept you need to be aware of in the world of reactive code. Observables this is now a shiur be'anglit. Observable is a conjugation of the word to observe, which means you are now observing something. What are you observing? What is the subject of your observation? What is it? The data. Ken said data. Nachon. It is the data. You are observing the data stream coming to your application because the data is flowing. But if you don't observe it, this is an active action. You need to do something. Do you know what you need to do? You need to subscribe to the data. And unlike your Netflix subscription, you can easily unsubscribe as well. It's amazing. So you need to subscribe. Now, observables have 4 key traits that define them in your application. First of all, they are lazy. Not lazy like before their first coffee in the morning, but lazy like in the fact that you have to take an action to observe. They also are cancelable, unlike your streaming services or your hot cell phone plan. And they also emit multiple values at the same time. You can get multiple pieces of data streaming through synchronously. And they signal when the data stream is done. So not only can you cancel them, they're also really, really helpful. Can you imagine if most of your life was as helpful as this? It would be we'd be living in Gan Eden. It would be amazing. We would all be so happy. So knowing these 4 key traits of observables, how do then we transform that data once we're observing it? Well, we use operators. Operators allow us to, again, עוד פעם שיעור באנגלית, to operate on a data stream. And the operators we're going to cover briefly, well, I know every single person in this room are familiar, I don't know which one to use, I'm not that great in English, is familiar with the operators we're going to see in a second. But these operators allow you to take the data coming in and to transform it, to mutate it, to shape it, to use it the way you need to use it. So what are those operators? Well, first of all, there's map. Who's ever used map in anything? Every hand should raise. Every hand! Map allows you, of course, to transform each value in a function. So for example, let's say you're taking in a data stream of flights coming through Ben Gurion Airport, and you want to map them into a concatenated string. That's exactly what map would do for you. It would take them and put them into a string concatenation. That's map. What about filter? Filter lets you only pass the values that meet a condition. So let's say you want to find only the flights that are delayed. Of course, delayed flights never happen out of our airport, ever. Everything is always on time, perfectly run, the best airport in the world. But let's say you want to find, on the occasion, a delayed flight. You would use filter on that data stream to get that delayed flight. Now, merge allows you to combine multiple streams into one unified stream. So let's say you have data coming in from terminal A, data coming in from terminal B, and you want to combine them into one unified stream. Well, then you would use merge for that. And lastly, but certainly not least, acharon, chaviv, we have buffer. Buffer lets us collect the values into arrays and then act on them when a trigger occurs. Any kind of trigger that you signify in your code base. You can set it aside, keep the data there to act upon it when that trigger happens. Okay, operators essentially allow you to, instead of writing things imperatively, you can shape and combine streams with declarative code. That's the beauty and the purpose of using operators on your observed data stream. And if you remember one thing, remember this: if you don't observe the stream, it did not happen. It's not even there. So once you're observing the stream, you can then operate on it with these and many other operators. Okay, enough talk though. Let's actually look at a brief couple examples of how this may look in some real world use cases. First example, maybe you want to stream data in your Node.js application from a Postgres app. You know, we all love Postgres. We even put vectors in Postgres for some odd reason. I don't know why we do that, but we force it into the relational database. But let's say we want to use our Postgres app and we want to stream that data into our Node.js application. Well, the way you would do that, well, let me further example. To give you a further picture of where we're going, you want to stream all the flights that are boarding on that flight. Now, on any single plane, there may be 400, 500 people on a single plane, but what if you want to stream all the flights boarding that day out of the world's busiest airport? That's a lot of flights. That's a lot of people. You may want to use reactive programming paradigms for that. You right there, you may want to use it. Reactive programming paradigms for that moment. So the way you would do that, you would stream the rows instead of loading them all at once. And essentially the way it would look like in your code, first you'd import your dependencies. In this we're using RxJS, a very common dependency for reactive programming. And you notice that we are wrapping our event stream. First we subscribe to our event stream, which is our database. And then we are wrapping it in an observable by declaring and instantiating a new observable object. And as the data comes in, we can operate on that data. This, of course, is a very simple example at the very bottom there, right? Flight row subscribe. Very simple. We're just console logging out what's happening, but you can imagine you can extend this to a fully robust application for flight boarding, right? Or any other thing. Standing in line to get your lunch from wherever or anything, any queues. You can manage the data as it is coming in. You wrap the event stream in an observable, you act upon the stream, and then you subscribe. In the very bottom is where you subscribe to that stream. Essentially, you're transforming the data as it streams. Instead of fetching the data, right, making well, first of all, in your database patterns, you should probably avoid select all from a table, but Okay, not the best. If I was still working at my database company, I probably wouldn't give that as an example. You shouldn't select everything from a database stum. But let's say instead of just selecting everything from a database and then working on that big data chunk, you get to work on the data as it comes through into your application iteratively, as opposed to needing to do it all at once or handle a massive chunk of data at the same time. Another example, let's say you're dealing with smart contract data and you want to stream that into your Node.js application. So the example here is another data source and showing you that it really doesn't matter what the data source is. Some of your most common examples will be databases, but it could also be overly complicated databases that cryptographically signed. It could be any kind of databases. It doesn't matter where your data source is coming from. So let's say it is a smart contract data, and the use case is a membership rewards program. We all know that the El Al membership rewards program is the best one in the universe. Nothing is more generous than the El Al Matmeed program. Little sarcasm in the morning. But let's say you are in the El Al Matmeed program, and you have tens of thousands, maybe even a few million members of this program. And they want to use it to bid on upgrades on that flight to Bucharest or wherever people go. They want to use that to buy duty free at the end of the flight when they announce on the boarding that in the last 10 minutes, come to the back and buy duty free. They want to use it to buy tickets, to transfer tickets, to complain, to do all sorts of things. Each one of those things, each one of those actions as a back-end developer, you know that each one of those actions is something that's happening in your data. They are using credits to do something. They're using credits to buy, to purchase, to upgrade, to transfer. All of those things need to be dealt with in your data. Now, as a user of this Air Rewards program, you, of course, don't want your users to have to wait more than, how long do you think they should wait for? A second? 2 seconds? What's the patience of somebody before they complain and say, yesh delay, or something like that, right? So how long are they going to wait for to get the result? Not that long. So you need reactive, using the word, you need reactive programming for your membership rewards program. So just like the other example, instead of using the PG library, we would use a smart contract library, in this case ethers. You should probably use Veeam instead, but whatever. We're using ethers. And we wrap the contract, we import the functions, and then we wrap that in an observable from an event pattern. We watch the contract being turned on, being turned off, and we handle the contract. And then we use that raw data into, well, in this case, another concatenated string into readable alerts for the user. But once again, string concatenation could be any use case. It doesn't need to be string concatenation. It could be more further data transformation, could be actions impacting the user in their membership program, transforming behavior, all sorts of things happening as the data is streaming into your application, as opposed to having to happen in chunks as the data, you fetch the data and then you work with the data. And I'll show you a brief example. Now, caveat, I am not a front-end developer, so don't judge me based on this AI-generated front-end. This looks like every other Tailwind React AI-generated front-end that has ever been seen on the internet. So just as a caveat, but it's a very simple example. But essentially what I want to show you, if this plays, you have your airline miles program, you check in for your flight, you pay for the check-in, that's a lot of ETH you're paying for, but whatever. You check in for the flight, and within just a couple seconds, you've earned another 1,000-mile reward program. That is happening real time on a blockchain, happening with real data and real user. Again, in the magical world of localhost, where everything is possible on your own computer. But the example being that this is not hard to do. You can start using this right away to essentially, whenever you have the situation where your data is, where your application is dealing with high throughput streams and event-based data. So think about that, right? Event-based data, high throughput streams, real-time interfaces. Those may be your clues that maybe I should look at reactive programming as a paradigm, as a model for how I either build or refactor my application. Because it's ultimately about the power of not fetching the data. That's what it's all about. You're going to walk out of here thinking one thing: don't fetch data. Let the data come to you. Don't be mysterious. Wait for the data to come to you. Don't be the guy going to the room and aggressively reaching everyone. Stand there as the mysterious gentleman waiting for someone to approach you. That is the reactive programming paradigm. Now, before, in the previous model, and what you may be used to, you make multiple database queries inside a for loop. We love for loops. What is more efficient in time and space than for loops? Instead of multiple database queries, you stream the rows from the DB. Instead of a promise.all on a large query result set, you transform the data as it comes in. And instead of memory usage, you get consistent, instead of memory spikes, you get consistent memory usage. Have I sold it to you a little bit? Yes, great. I've sold it to you. I've done it. Oh, nice shirt. Very gold there. That's very shiny. Can always find you. You belong in the US with that shiny gold. So stream it. I've sold it to you. You're now all reactive developers. Stream gives you structure, and the observables give you the power to manipulate that. But beware. Buyer beware. Reactive programming is not magical. It's not something you could just drop in and not worry about it. There are some problems which are more intuitive, some problems that are less intuitive. Some problems are kind of like the same as asking somebody, hey, my computer's not working, and you say to them, did you plug it in? Some of these problems are similar to that, and some are a little less intuitive. Let's cover 4 key areas that I've actually seen quite a lot with developers working with reactive code. One is kind of ki'ilu, did you plug it in? Did you subscribe to the data? You're trying to transform with operators on a data observable, but you forgot to hit subscribe. You forgot to call subscribe on the stream. And then, maybe less intuitive, did you unsubscribe to the data? This is really important as well. Why are we introducing reactive programming to begin with? We're introducing it to deal with large memory spikes, large memory issues. Do you know, if you don't unsubscribe to a data stream when you don't need it anymore, you may be introducing the very same problem that you are trying to resolve. And then you'll come back to me next year at NodeTLV and say, Ben, you ruined my code base. It is even less performant than it was before. And I'll say to you, did you unsubscribe? You're like, oi, I forgot to unsubscribe. I'm so sorry. Of course, that's what's going to happen. Similarly, the order of your operation chain also matters. Now, of course, it matters on the logic of your code, right? If you call one operator before another operator. But even when the order could make sense, there are performance impacts as well in the way you order your operators. And last, but certainly not least, events need mutability. The read-only ones, read-only events, are restricted from side effects. So therefore, your data, your mutable functions, need to emit events. You need to have mutable functions, not immutable functions. Okay, what do you do with all this? Where do you go from here? Well, I am here to tell you, you can start today. After you've done collecting all your swag, and you've signed up for every recruiter and all of their emails, and you've given away your biometric data for a plushie, and you are ready to start being inundated, and you want to sit down on a small break, and you see these guys with the QR codes, they want your biometric data, and you sit down and you want a small break, you can start doing this right now during the break. In the noise, in the crowd, with a nice cup of coffee from the barista, you can actually start doing this because you've seen how to stream from a database. You've seen how to stream from on-chain events. You understand some of the major pitfalls. My friends, you are ready. I believe in you. You can start this now. And you can try it yourself with this GitHub repo. This GitHub repo has no tracking on it. I don't care if you use it or don't use it. I am not looking for any metrics on it. It is a simple, fully functional, full-stack application with reactive patterns using RxJS built into it. You can clone that repo. You can play with that repo. You can ingest that repo into your IDE's LLM and tell it to play with it. You can do whatever you want to do, however you code today, whether it's you coding or Sam Altman coding on behalf of you with his LLM, you can do whatever you want with this repo. And it's a fully functioning one. I find that I learn best by breaking things. That's just how I happen to build. Some people watch YouTube tutorials, some read books. You should definitely read books on vector search, by the way. Some people read books, some people do other things. I like to clone things and just break it. And that's typically how I learn, which is why I built this to help myself learn how to use it. Okay, so you got that repo, you're ready. If you need a link to that repo after, you can also find me and I can send it to you as well. But remember I mentioned that there was a duck hunt? There's a duck hunt, right? You want those tokens or whatever they are. They're in my pocket, whatever these things are. You want these tokens. There's some fantastic prizes that I don't even think you need to give away your biometric data for. I think you could just get the prizes and go home anonymously. You'll just use your on-chain identity. Remember, I work at a blockchain, so on-chain identity. You'll be totally anonymous. If you want that token, if you want to win those prizes, I'm going to ask you something. And this, of course, is tied to my sense of, did I do something here or not? Did I work on anything beneficial for you or not? So help me answer that question by tweeting your answer to this question. What should be a stream in Node.js and not a fetch? What should be a stream in Node.js and not a fetch? Now, I made it super easy for you because I am eminently lazy. If you scan this QR code, it will open up Twitter for you and start the tweet. All you need to do is just finish the tweet. And if I like your answer, I'll give you a bunch of tokens. Really easy, really simple. I think there's some fantastic prizes. This is like probably literally one of those low effort things you can do to win those tokens. So I don't see enough phones out. That's actually very embarrassing for all of you. Do you not want to win things? I don't understand. But this is your chance to win by tweeting out what should be a stream in Node.js and not a fetch. Thank you all very much. I hope you enjoy the rest of your day.